Welcome back to Gemini Exploration Series. In the past few videos, we have been talking a bit about how you can start using Gemini API for all of your use cases. And we talked about context caching, how can you start using it for different use cases. But today I wanted to focus a little bit more around how do you run all of these things onto your local machine without having to send any information back to Google, or if you end up using any other models other than Gemini, to those providers. So how would you get this done? So good news for you that Google has just launched Gemma 2. I was actually going to make this video on Gemma 1, but Gemma 2 is finally launched and we can talk about it. So here's Gemma 2, which is available now for researchers and developers. Gemma 2 actually is much better in performance than Gemma 1 and other open source models that are out there available. And the best part about this is it works really well with other hardwares and easily integrates with other AI tools that are out there. So this is the blog post. They released two different models, 9 billion and 27 billion parameter models. They talk about how AI has the ability to address problems, and they talk about the last releases that they did around Gemma models. With Code Gemma, these are different Gemma models which are trained for specific tasks. So Code Gemma, Recurrent Gemma, and Pally Gemma are around like Code Gemma is for coding, Recurrent Gemma is for, I think, RL models, Pally Gemma is more for images and videos, and these are accessible through Hugging Face and NVIDIA and everywhere else that you would find the models. With Gemma 2, they have released 9 billion, 27 billion parameter models. 9 billion parameter model is small enough to fit in small GPUs on your machine, and 27 billion GPU parameter can easily fit on a GPU that you have on server side. So H100s can easily host this 27 billion parameter model. So that allows anybody to start using these models on, oh yeah, Tensor Core GTU. Okay, sorry, I read it wrong. Yeah, so it allows anybody to start using these models as soon as you can start, as soon as you want to, I guess. Okay, so why you should be looking at Gemma 2 versus any other models. So there's a technical report attached here. We won't go into details around that, but at 27 billion, Gemma 2 is actually delivering performance better than some of the much bigger models. And I think they compared it against Llama somewhere. Yeah, right here. So they compared it against Llama 370 billion parameters. It's not to the same level, but it's going very close. So a model which is close to half the size in here, or even more than that, it's performing much, much better than what you would expect a model of that size to perform. And 9 billion parameters model is actually performing much better than the 8 billion parameter model that is from Llama's side. Now, I understand 9 billion versus 8 billion, you would expect it to be different, but Gemma models are by themselves performing better than that's outside. And again, all of these are based upon these benchmarks. Your mileage might vary based upon what you're trying to do, the way you are doing it, like different prompting techniques, different data inputs that you're feeding to these models, tools that you're providing to these models. So your mileage might vary with that. The thing that I really like with them is like the cost saving part of this and efficiency, because these models can easily, with full precision, fit on a single TPU host or these GPUs. It reduces cost, but still maintains your high performance or high accuracy of the models. So it allows for budget-friendly deployments on the AI side. Then it's of course done. They have done a lot of work, and they are working with NVIDIA and like Gemma CPP to make sure that the model works really well and gives you good performance on your hardware that you have probably at home. And like even with Gemma CPP on your CPU as well, so you can try it at your home as well. On the licensing side, they talk about how it's open and accessible. They have a Gemma license where it's commercial friendly, so you can start using these models today to start building whatever you're trying to do. This I really like about Gemma models is they have really broad framework compatibility. So we already talked about how you can use it with Llama CPP, but here they go in more details around how with Hugging Face, Transformers, JAX, PyTorch, whatever you're using, it supports almost everything in there. It's they are working with NVIDIA NeMo and NVIDIA NIM to make it more optimized for those microservices platforms. And they are actively working on more parameter efficient fine tuning options. Starting next month, this was, I thought, why is this missing? And then I realized they added it as a new thing in here. Is starting next month, it will be available on Vertex AI, so you can, on GCP, you can build and deploy it directly. They also go into details around responsible AI development as well. They talk about LLM comparator tool. I will have a new video on this soon. and then we go talk about they are actively working on open sourcing their text watermarking technology, SynthID for Gemma models. So SynthID is right now available only for Gemini models. I'll probably make another video around that. SynthID allows us to figure out if the content was generated by LLM or not, and you can use SynthID as a way to detect AI generated content. I actually don't know how well it works on the images on the text side, but I think it should work really well on images and video side. Okay, moving on. So they talk a little bit about more metrics. These are the metrics and benchmarks that they're looking for when it comes to responsible AI. They also ended up highlighting this really cool project from India, Navrasa, which talks about how different Indic languages are being retrained on top of Gemma to create models which allows very linguistic diverse Indian population to communicate with each other. And this video is really cool. If you get some time to take a look at it. And of course, you can start using this today from Kaggle, Hugging Face, and Vertex Model Garden soon. Okay, so I ended up opting for doing it on Hugging Face. So you can come in here, Gemma 2B is available. The model is gated, so you will have to confirm for the permissions. And when you do that, it will actually, its permissions through Kaggle. So this is where actually the model resides. The model was published just recently, and then just a few days ago from today. By the time this video comes out, it might be a little bit more than that. And then it talks a lot about around like what is the input, what are the outputs. Like this is the complete model card in here. So it goes into details around what is the training data set, what was the pre-processing that they did. So CSAM filtering allows the models to not learn on these materials. Similarly, they also remove sensitive data. So if you had your phone number or other personal information in these data sets, which might be there because you might have posted about something online and then or some data breach happens and those documents get available. So these pre-filtering allows these models to not get that access to that information and thus retain your personal information is not retained in the model. It's not available to the model for training at all. Similarly, it goes into, okay, it was trained using TPU. I think to note in here is only on TPU v5. TPU v6 was released recently, but Gemma model is not trained on those. I'd have to know more about why. Or are there plans for it? Or maybe it was not needed because I'm assuming TPU v6 is high in demand internal at Google as well. It talks a lot about how it works really well within TPUs and the cost effectiveness of TPUs and training these models. It also talks about software that was used, ML pathways. This was talked about by, I remember Jeff Dean had a good blog post about this. Essentially, it talks about the software that was used to train the model, which is JAX and ML pathways in here. And then it ends up giving a really good foundational model. And they go to the same benchmark evaluations in here, same as the blog post. They talk about ethics and safety considerations that they did, some evaluations. And then they talk about intended usage. So you can use this for content creation, communication, and research and education. And then, of course, they have a limitation section in here, which is generally these limitations are going to be true for all sorts of models, but specifically for a model that is available to you locally where you download the model. So this model is essentially, think of it as when it was released on 27th, it actually probably stopped training for like some time ago before this. So it does not have any information before that point. So one of the things that they specifically highlight in here is training data, that the data is either biased or the quality is old or the factual accuracy of the data might be, since the data is older, it's outdated. So you have to be aware of that. And of course, common sense. Some of these things will apply to all models. It doesn't matter whether they are online or not, whether they are online or offline models. In this case, Gemma 2 is going to be offline. They also talk about bias and fairness in here, misinformation and misuse, that people can use these models sometimes. You can ask the model to think like in a fictional world, and based upon that can generate things that it thinks is true, but it probably is misinformation, and people can use that as a misuse for that. It goes into more depth about risks that they have identified and the benefits that they're looking for in here, and they especially focus on the benchmarks. Okay, so to start using this, you can start using this in different languages as well, different frameworks as well. So there's Keras in here available, and they have different instruction-tuned versions and normal language versions in here. They also have PyTorch models in here. I ended up using the PyTorch 9 billion instruction-tuned model. They also have pre-trained models, so this would be useful if you wanted to retrain this model for your own use case. This, of course, it's available in C++. I actually don't know what GGUF is, but I would take a look at it afterwards. Um, Either way, I ended up using PyTorch model. So let's go take a look at it. Okay, so here's Gemma 2 on my Colab. These are standard installations if you're trying to use anything from Hugging Face Transformers. And Transformers is the library that we'll be using to load the PyTorch model and then start using it. Since the model is on Hugging Face and it's behind a gated model, we have to pass in our Hugging Face API key. So we are getting the Hugging Face API key and passing it to download the model. And remember, the model that I'm using is 9 billion instruction tuned model. Okay. So I have actually L4 GPU that I was using for this. Ran it on that. Used the whole B float 16, and of course passed in the auth token. It downloaded the model, fairly small size, not really big, but it ended up consuming most of my RAM that I had on my GPU. And then once the model is downloaded and loaded, you can start asking it to give you responses. This is the default method that you would find even in the documentation right here on how to start using it. But we ended up this essentially, actually, this is a really good way to take a look at how the model actually works. So we take a token, we take a text, we tokenize it. So these models don't understand the text as is. You have to first tokenize the input. So we take the input, we tokenize the input, and we return tensors and into the CUDA. So these are the input IDs, and then we pass these input IDs to model to generate the response, and we give the model a max length. I think the max length, if you don't define, is 20 characters or something. So you might have to define a max length in here to increase the output to be more than 20 characters. And then once we have the outputs, we decode the outputs to see it back in the text. Otherwise, you'll be seeing the embedding values. So another thing to note in here is these are some special characters that the model has within itself, which are useful for model to understand where's the start, where's the end of sentence. So this is beginning of sentence, this is end of sentence, and this is end of turn for the LLM in here. You see that it does the output in here, and this output looks like it's marked down. So what I ended up doing is I took the response from here and wrote a small quick function which will take the output and put it into Markdown. I also cleaned up the special tokens in here, cleaned up the tokenization spaces, and the rest of the function remains same. And it just like uses IPython display to render the Markdown text. Then we try to run the function here again, and we ask for using Gemma over Gemini. It does a good enough job in here, actually, fairly good job to say because the model is transparent, like fully available, all the weights are available. It's fairly transparent, not the same transparency if they also released all the training data that they used and everything around how they trained. They did release a lot of these details, and that's why Gemma is much more transparent than what Gemini is because you don't know all the details around Gemini. Of course, there's a paper out there, but there's still some more things. The size is smaller, so you can probably fit it onto a local machine. There's fine-tuning flexibility as well. And then, of course, you will see a lot of community development, which we already saw in the blog post where community in India ended up building a Navrasa model on top of Gemma model. Yeah. Okay, so similarly goes to talk about what Gemini can offer you, which is of course higher performance and multimodality, and backed by Google Research, where it will keep getting updated and updated without you having to worry about getting new model and figuring out how to make it work with everything else that you have. We see that it actually works fairly well, 39 seconds to get the response. Not really fast. Like, I'm assuming if I did the same thing over Gemini API, you'll probably get this much faster. But then again, that's one of the things that you are trading off between having the model available to you locally and being able to do everything that you want with that model versus opting into any permissions or any kind of terms and conditions that you have with Gemini or using Gemini on the platform provider side. So now, um, another thing that I just quickly wanted to highlight that the models can also generate code. But if you actually wanted to use code generation capabilities, you should be looking at one of the models that were mentioned in here, Gemma, Code Gemma, I think that's what it's called, somewhere here. Oh, yep, right here, Code Gemma. So you should be looking at Code Gemma. I think Code Gemma is still in 1.x, so you might have to wait for the version 2 to come out. Oh, Code Gemma 2b is available. Nice. So yeah, you can start using Code Gemma 2 as well. So that probably will be much better and faster than Gemma 1 for code. And yeah, it does generate the code. So I asked it to write the Python code for Gemma using AI Studio API. So this is the actually next feature that I wanted to show you. So it wrote the function. It works really well. I think there's a lot of fine tuning that the team has done to always. This is the same thing that I have also found with Gemini, where it would return the response, but then also provide some explanation. I actually really like this because it talks a little more about not just giving you the code, but also allows you to learn. And then it also gives you details on like what should you do before you can start running it. We see that it took 50 seconds to generate this. Again, all of this is based happening on my local machine. And this is not really local machine, this is Colab. But these models, you can take these models locally and run it on your own GPU machine. I'm on a MacBook, it doesn't have GPUs. But you can do this on a machine that has GPUs and start running this on your local machine or onto a cloud provider as well. Okay, one last thing that I wanted to show you is this live local section where if you want to figure out if Gemma 2 is actually going to be useful for you or not, or if you want to just play around with it and see how good it is compared to whatever you have in production today. It's never going to be a 1:1 comparison because the prompting techniques are different. The data that your model has access to in production is probably going to be different. But this at least provides a good way for you to come in and start using or trying out this model without having to go through getting the model set up on Colab, paying for these L4 GPUs, or anything like that. So you can just come in here, and what I have done is selected Gemma 2 model uh, in these run settings, and you can start using that to build and to ask questions and get the responses out. So yeah, give it all a try. Let me know how things go. And if you have any questions or any more use cases that I should be looking at around running local smartly, please let me know. Anyway, have a great rest of your day. Goodbye.